Hello everyone, I'm Norman Wahlberger, and we're talking a little bit about the mathematics of music. And I want to talk about scales today, and in particular look at the melodical framework of music from a mathematical point of view. So looking at what's actually foundationally at the bottom of things. So in the Western world, we're all sort of used to a certain kind of melodic structure based on the standard scale, represented, say, like with some chords like this. Okay, so that's a very familiar kind of pattern, which is built up from the notes in a scale. And a scale is a sort of a specified sequence of notes that have a particularly harmonious relation to each other, at least from a certain cultural point of view. But it turns out that there's quite a lot of variability in this. So it's maybe a little bit easier for me to explain on the piano. So on the piano, the architecture of the instrument already dictates a sort of preferred scale, which is the C scale, because it only consists of white notes, okay? Starting with C, D, E, F, G, A, B, and then back to C. So there's actually 7 notes in that scale. Usually people say 8, but that's not entirely true. There's really 7 distinct notes, and then it repeats, okay? And the black notes that are on the piano are not involved in that C scale. So when we look at those chords that I played, well, there's the C chord, which is just the first, third, and fifth notes of that scale. And then there's the F chord, which is the, I guess, fourth, the sixth, and then the eighth one of that scale. And then the G chord, the 5 chord, these 3 notes, okay? So the chords are created from the notes of the scale by sort of choosing nicely spaced combinations. But there are variants to that, lots of variants. For example, there's the minor scale. But there's actually all kinds of other scales, like this one. Maybe that's an Ionian. Another one. They have various names like Dorian, Ionian. I forget what the other ones are. That may sound a little bit funny, right? But these alternate scales are, in principle, legitimate kind of frameworks, and in fact they are used quite extensively in modern jazz. And then if we go to other cultures, like we go to maybe Asian cultures, Chinese, Japanese, we find a pentatonic scale involving notes, 5 notes. And then back. That's a very popular scale. In Bali or in Indonesia, there's a sort of gamelan scale, which I think is something like this. So it's 1, 2, 3, 4, 5, these particular notes, okay? So there's actually quite a lot of cultural variability, and what sort of sounds natural to one person may not sound that natural to another. So from a mathematical point of view, how do we approach this? Well, if we adopt this well-tempered approach that I told you about in my last video, and so let me remind you, the idea there is that we're looking at these various ratios that the Pythagoreans discovered, perfect fifths, perfect fourths, etc., and also other ratios which were easily determined in terms of just ratios of natural number frequencies. Then it turns out somewhat miraculously that those particular intervals sort of fit into a framework that you can get by going from the octave, from this note to this one here, so doubling the frequency, by dividing things equally, sort of in terms of equal ratios, into 12 exact pieces. So that's like taking a 12th root of 2 to create the various steps in this sequence. And the reason why that's nice is because then these perfect fourths, perfect fifths, the sixth, the third, etc., they fit pretty closely to the intervals that are obtained this way. So the untrained ear has a hard time distinguishing between a perfect fifth, a real perfect fifth, and this perfect fifth, which is not a real perfect fifth, but it's pretty close. All right. So that's a big advantage, because then it allows us to shift. So we don't just have to play in the C scale, but we can play in some other scale. And people who play the piano or other instruments have to learn these scales in all these various keys. And it's the well-tempered aspect of our instrument system that allows us to do that smoothly, so that one key sounds very much the same as another key. So if we are thinking in that direction, we see that if we want to transcend our own particular cultural orientation, the really truly sort of fundamental scale that sort of underlies all these stories is the chromatic scale, consisting of these 12 tones themselves. Right? Here is the chromatic scale, starting, say, on C. And then back to C. So there's 12 notes there. And all the other scales, or most of the other scales that we find in jazz, in rock, in other cultures, in classical music, are built up from subsets of those 12 notes. So that's a good place to have sort of a framework from a mathematical point of view, isn't it? So what might we call these notes? Well, on the guitar, this of course also has a very natural interpretation. It just corresponds to the various frets going from the open position to this octave position. So going up, or actually going down, because is up really more natural than down? Down is perhaps just as natural. So let me remind you that the frequency of the string is going up when the length of the string goes down, right? So we're going up in frequency here, in tone, while the actual string is going, getting shorter. Now, so what should we call these notes? We need a system for being able to tell us where in this scale we are. And there's a natural system. Actually, there's probably two natural systems, all right? On the piano, the standard thing is to have letters assigned to these values. That's C, that's D, that's E. But then these other ones here have to be sort of secondary things. So this one here is called D sharp, because it's just a little bit above the D, or E flat, it's just a little bit below the E. So we end up having this rather convoluted terminology for the names of the notes on the piano and also on the guitar. And that's so heavily entrenched in Western music that we don't think anything of it. But actually, from a mathematical point of view, it's not really very natural. So what is the natural naming system? Well, I suggest that there are actually two natural naming systems, one going up and one going down. Okay? So the one that I sort of told you about last time, it goes down. So let's start with that one, because it might be a little bit more unfamiliar. So if we start with the octave, okay, that's sort of like the bass thing, and we're going to go down. Well, we're going to go down in steps. So right now we haven't gone down at all. We're at the top. Da, da. Let's call that 1. Maybe N1 for note 1. N2, N3, N4, N5, N6, N7, N8, N9, N10, N11, and N12 gets us back to the octave. That would be one reasonable way of naming notes. Admittedly, that would be a little bit odd because we're starting from the top and going down. Much more familiar would be going up. So let's talk about that, okay? So going up, we would start with an open string, say, and we can go from here all the way up to here. So we're going to name the notes. That's 0. Let's use M, okay, as opposed to N. So up we'll use M, down we'll use N. So M, M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, and M12. On the piano, we could start at any note, but let's start at C. So that would be M0, M1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then M12, but that's really the same as M0 in terms of the octave equality or equivalence that we have. Now that takes some getting used to. So, from this point of view, we can now refer to notes and combinations of notes with numbers, and these numbers sort of very clearly tell us where we are in the chord. And this has a big advantage sort of for analysis and sort of theoretical work, because we can more clearly see the patterns that are going on. And it frees us a little bit from this dependence on the usual major and minor scales that Western music is largely built on. So in particular, so there's C, that's 0, note 0, M0. Okay? The fifth, what we used to call the perfect fifth, remember I told you that we're going to maybe introduce a new name for it? That note is actually 1, 2, 3, 4, 5, 6, 7. That's actually note 7, M7. And the fourth, that's actually M5, 1, 2, 3, 4, 5. 5 and 7 then are the kind of key building blocks in the usual sort of way of thinking about things in terms of the basis of the chords that I played you at the beginning. 1, 4, 5. It's really sort of 0, 5, and 7 that we're building on. The sixth, well, that's 7, that's 8, that's 9. The sixth is number 9. The major third is number 1, 2, 3, 4, and the minor third is number 3. Okay, so that's a pretty interesting way of thinking about things, and I think it does shed some light on some things. So I offer you that as something to think about, and we're going to see how that helps us understand a lot of harmonic constructions a little bit more naturally from a mathematical point of view. I'm Norman Wildberger. Thanks for listening.